Assalamualaikum and hi everyone. So in this video, we are going to learn about acid-base titrations. So at the end of the lessons, you should be able to describe the titration process, distinguish the endpoint and equivalence point. Titrations is a procedure for determining the concentrations of a solutions of unknown concentration using another solutions with known concentration that called as standard solution. So this is the titration setup. So the solutions in the burette is called as titrants, and usually we know its concentration. And the solutions in the conical flask is called as analyte, and it has unknown concentration. So there is also an indicator that we use to determine the endpoint of titration. So let's see the titration process. At first, measure out 25 cm cube of hydrochloric acid using a pipette and transfer to a conical flask. So the solutions in the conical flask is called as analyte. Next, we fill burette with sodium hydroxide solution and we take initial reading on burette and record to 2 decimal places. So the solutions in the burette is called as titrant. Next step. We add a few drops of phenolphthalein that we use as indicator, and then we start the titrations by adding sodium hydroxide until the indicator changes its color. So for the phenolphthalein, the initial color is colorless, but after that, it changed to pale pink. So we stop the titrations here, and we take the final reading of burette. So the moment of the phenolphthalein change its color to pale pink, this point we call this as endpoint, which also equal to equivalence point. What is meant by equivalence point? The equivalence point is the point at which the amount of acid and base present exactly neutralize one another. So at this point, the number of mole OH minus is equal to number of mole H3O plus. Since it neutralize one another, it will produce H2O. And at this point, the neutralization is complete and no excess of acid or base. Next is endpoint. The endpoint of titrations is the point at which the indicator changes color. So let's say we want to neutralize acid with base. So we put a few drops of phenolphthalein into the analyte, into the conical flask before we start the titrations. So initially the color of solutions in the conical flask is colorless, but after that the solution start to change to pale pink. So we stop the titrations immediately, and this point is called as endpoint of titration. But if you continue to put the base into the conical flask, you will get kind of a deep pink, and this is the pass endpoint. There are 3 types of acid-base titration: strong acid, strong base titration, strong acid, weak base titration, weak acid, strong base titration. So please take note that weak acid, weak base titration is not normally done because the equivalence point cannot be accurately observed. So let's see the titration curve of strong acid and strong base. Example, acid-base titration is carried out by adding 0.1 molar sodium hydroxide dropwise to 25 ml 0.1 molar hydrochloric acid. Sketch the titration curve to show the variations of pH against the volume of sodium hydroxide added. So in this case, sodium hydroxide is in the burette and it is a titrant, and the hydrochloric acid is in the conical flask and it's also called as analyte. So here is the chemical equations for the titrations. So HCl plus sodium hydroxide, we get NaCl plus H2O, and this is the titration curve. So we plot pH against volume of alkali added. Remember that alkali here is called as a titrant. There are 4 important points that we are going to be discussed here. So the first point is point A. This is the beginning of the reactions. Okay, so at this point, only strong acid present in the conical flask. So it has high amount or high concentrations of H plus and low pH value. So the starting pH is at 0 or between 0 to 1. Next is point B. This is any point before equivalence point after additions of titrant, sodium hydroxide. So as you put some amount of sodium hydroxide into the acid, what happened to the pH? The pH will increase gradually as acid is neutralized by the added base. And then as you reach the 25 ml volume of alkali, you got the equivalence point. So this is the point C. So at this point, there is equivalence amount of acid and base being mixed stoichiometrically. So the concentrations of H plus is equal to the concentrations of OH minus. And the pH value is determined by the type of salt formed by the reactions. So for these titrations, since it's between strong acid and strong base, we get a neutral salt. So since it's neutral salt, the pH of equivalence point is equal to 7. And D is the point after equivalence point. So at this point, you continue to put the sodium hydroxide into the conical flask. So what happened to the pH? The pH will increase slowly because there are more amount of OH minus compared to H plus.